is the quiz for integration. Just quickly go over it for those that need a bit of extra help. So we want to do the integral. So I'm looking at the bottom part here, and I try and think what would differentiate to that. So over here is my first guess. I think it's 1 plus e to the 2x minus 1, because when I multiply by the power and reduce the power by 1, and then times inside the brackets multiplied, so e to the 2x differentiates to that, plus my c. Then what happens when I simplify all this? Negative 1 times e to the 2x stays on the top, and this bit here goes down to the bottom, plus the c, which I need to put in there as well. And then, no, because I'm differentiating it, I don't need that, of course. So then I look at this and see, well, how does this differ from the question? And there's no 2 there in the question. So that means that this here needs to be halved. And there's no negative in the question, so I've got to times it by negative a half. So that's where this negative a half comes from, and therefore I have integrated it. For the next one, we've got the ship. It's the trapezium rule. These distances here are 10 apart, and so that's where the height is 10 there. Your initial values, y0, is this one here, and your last value, yn, is that one there. Everything else is doubled, so 2 times 150, just add them up, and it's 5 times 2800, which is 14,000 meters cubed. That's straightforward, just plug the values into the trapezium rule. Find the integral of this. Now this one won't differentiate very nicely, integrate, so what we do is we divide, use long division to divide the bottom into the top there. So when I set it out, I get x plus 1, and it goes into, I get the x there multiplied, I get x squared plus x. I need to subtract away, and then I get 2x there. 2 times x plus 1 gives me this 2x, and 2 times 1 gives me that's just 2x there. Yeah, and then 2 times the 1 gives me the 2 there. When I subtract it away, I get a remainder of minus 2. So the first x is that one there. There's the 2, and there's my remainder, which will be minus 2 over x plus 1. Now I go ahead and I can integrate that with respect to x, add 1 to the power, add 1 to the power, divide by the new power. This is 2 times 1 over x plus 1, so that integrates to 2 logarithm of x plus 1. And so that's what we've got there, and there's your constant on the end. This one here, we've got it's a differential equation equals 2y squared, 2xy squared. So what happens when we differentiate it? I want to put this x to the other side, and I want to put this y squared to the other side. So I divide by y squared, and I multiply by the dx there, and that's what I get. Now that's y to the negative 2, and I integrate both sides, integrate this with respect to y. Add 1 to the power, that becomes negative 1, and divide by the new power. Add 1 to the power, divide by the new power. Cancel that out, it's x squared plus c, and that is negative 1 over y. Now if I times by the y, and come out onto the right hand side, divide by the x squared plus c, and it comes out to the left hand side. We're told up the top that y to the 0 equals a half. So that means that this side here is the half, and the 0 is the other bit there. So we got negative 1 over 0 plus t, c equals 1 over 2. So therefore c must equal negative 2 when you solve that. When you find that c is negative 2, we get y equals negative 1 x squared minus 2.